Sorry guys, this can be a little bit of death by presentation or death by PowerPoint, but we'll be doing a lab right after. Alrighty, little introduction. So Amazon Virtual Private Cloud, or VPC, enables you to launch AWS resources in a virtual network that you define. Remember that, virtual network. This virtual network closely resembles a traditional network that you'd operate in your own data center, with the benefits of using the scalable infrastructure of AWS. VPC peering is a networking connection between two Amazon VPCs that enables you to route traffic between them privately. With VPC peering, you can connect two VPCs as if they were a single VPC, and you can route traffic between them using private IP addresses. VPC peering does not allow instances in either VPC to access each other's private IP addresses, but it does allow you to create security group rules that allow access. VPC peering is useful for scenarios where you want to connect multiple VPCs together that are owned by the same AWS account, connect VPCs together that are owned by different AWS accounts, VPCs in different regions, and connect an on-premise data centers to VPCs using AWS Direct Connect or VPN connection. To create a VPC peering connection, you must request a VPC peering connection and have it accepted by the owner of the peer VPC, which I will be showing you guys here in a second. Once the VPC peering connection is established, you can create a security group rules to allow or deny traffic between the VPCs. In this diagram, which is not pulling up, let's see if I can go to the page resources and find it. It's like this. This is similar to what it looks like. Yep. And let me go back to what we were reading. In this diagram, VPC1 and VPC2 are connected through a VPC peering connection. VPC peering connection allows resources in the two VPCs to communicate with each other using private IP addresses. For example, EC2 that is in VPC1 can send traffic to an RDS database in a VPC2 over the VPC peering connection. Is that making sense to everyone? You could have two separate networks, right, and they're talking to each other. VPC peering is useful for scenarios where you want to connect multiple VPCs together. I think we established that. Okay. There are several reasons why you want to use VPC peering. To allow resources at a different VPC to communicate with each other, and staying within AWS network, not going over the internet. To enable a single VPC for multiple purposes such as development, testing, and production. To enable you to connect multiple VPCs together that are owned by the same AWS account or different AWS accounts. We went over that already. Okay, so this is that same picture. It's also shown here. This is an example to enable two VPCs to access resources from another VPC without restriction, assuming this is a single CIDR VPC. So the root table, there's one and then two VPCs, right? And in that route table, you were saying the connection here with the VPC A CIDR block as the destination and also going to B, and then likewise on the other one. So when you're setting up these route tables, you have to set up that connection on both ways. Does that make sense? Is there questions there? So if there's two VPCs, right, A has to be connected to B on that routing table, and B has to be connected to A on that routing table, since there'll be two separate routing tables, since there's two different networks. And then this is one peer to two VPCs in this example. And that would be essentially the same thing, but VPC A is going to be peered to B and C, and then VPC B would have to be paired to A only, and VPC C would have to be paired to A and connected up. Okay, so resource quotas and VPC peering connections for an AWS account. We would have active VPC peering connections per VPC 50. Seems like that's the max, and it is adjustable. outstanding VPC peering connection requested 25. Oh, so then a peering connection, this is probably like the base takeaway, is you have 1 week for that peering request on both sides to be, so one VPC would send that peering request and you have 1 week to connect or for that other VPC to accept that connection. So best practices, when implementing VPC peering in your AWS environment, it's important to follow best practices to ensure that your network is secure, reliable, and scalable. Here are some best practices to keep in mind. You need to plan your VPC architecture carefully. Before starting setting up your VPC connection, it is important to carefully plan your VPC architecture. This includes designing your VPC CIDR blocks, subnets, route tables, and security groups. You should also consider how many VPCs you need and how they will be connected to each other. Use unique CIDR blocks because your CIDR blocks cannot overlap each other for them to be able to connect. When creating VPCs that will be peered together, it's important to use unique CIDR blocks for each VPC. This is because VPC peering does not perform IP address translation, and IP address ranges in different VPCs must not overlap. This is important. There's one thing to take away: the VPCs CIDR blocks cannot overlap.
Do you have any experience with this at all?
I haven't had to do this in this way.
Okay. I'm just because it just seems like because of the way CIDR blocks from what went on last Saturday and everything like that, and what we learned, that would just sounds like a headache or like,
Number 3, minimize number of VPC peering connections. While VPC peering connections can be useful for connecting VPCs together, it's important to minimize the number of peering connections in your environment. This is because VPC peering connections are non-transitive, which means that you cannot route traffic through a VPC peering connection to reach another VPC that is not directly peered. Use of VPC peering for low latency applications. VPC peering is ideal for low latency applications that require fast, reliable network connectivity between VPCs. This includes applications that require real-time data processing, such as gaming or financial services. This could also come in very handy when it comes to, say, like a cybersecurity aspect as well. Just because say like you have analysts, right, you would want something that's near real time, and that's the hardest thing to kind of like get to when it comes to connecting multiple networks or data transfer. And then consider using AWS Transit Gateway for complex VPC architectures. If you have a complex VPC architecture with multiple VPCs that you need to be connected together, you should consider using AWS Transit Gateway instead of VPC peering. We're not going to be going over Transit Gateway today. We're only going to be going over VPC peering. But AWS Transit Gateway allows you to connect multiple VPCs together in a scalable, centralized way and provides advanced features like routing policies and network segmentation. Perfect. All right, so I created 2 different VPCs, right? Demo 1 VPC and Demo 2 VPC. If you look at the CIDR blocks, they're not overlapping. One is 10, all zeros and 16. And then in Demo 2, it's 10, 1, then zeros and 16. All right. Both of these have one private and one public subnet. From here, you're going to go down. You're going to click Peering Connections. And this is all in the VPCs tab. I already created mine, so we don't have to take time to let it load, but I'll show you how to create it. So just simply go to Create Peering Connection and then give it a name. So like Test Peering or Test Peering Preston VPC, like whatever, right? Then you would give the VPC that you want it to request. So say the requester, I'll do 1 with this CIDR block. And these are all under my account and they're all in the same region, okay? Part two of your assignment is going to be doing it with another region. This is why I'm having you guys work together on this, in groups of two. So there'll be another region, but then we would just select that next one, which would be the acceptor VPC. Then you can add a tag if you want. You don't necessarily need to. And then just do create peering connection. Then that would pop up with like a peering connection request. So under here, it'd just accept the request. And then you would have this, which for me, I named it demo peering. All right. And then after you accept the peering request, you need to update the route tables. So for a route table for the demo one, you go to routes, go edit routes, and then I put in a destination with that IP CIDR block for the number two. So this is for the route table of number one VPC. So I put the number two VPC IP CIDR and then did peering connection and then demo peering. So this is just the peering connection number. And then you'd have to do it. Remember, like in my little lecture that I was giving, I have to do it on both ends. So that's exactly what I did here. So then I did another destination with from demo 2 VPC to be routed to demo 1's CIDR, which is this one right here. And it was the same thing. Did peering connection and then that target.
Do you need the internet gateway?
No. You do not. VPC peering does not use the internet. Okay, and then I did the network for the NACLs, the network ACLs or access control list. These ones need to be labeled. I didn't label them. But this is where we're going to set up for pings and for SSH. I believe this, yeah, this is for demo 1 VPC. So then I did inbound rules. I set up rule number 22 for SSH. And then I did for ICMP, that's what ping uses. That's the protocol ping uses when you're trying to ping the other EC2 instance. Have you guys used ping before? Just to try and establish like, hey, like these two servers aren't talking, you can actually see there's a connection there. How you do that is you edit inbound rules, which is simple. That's rule number 22. This one you can really name these whatever. And then the type SSH, type for ping was all ICMP IPv4. And then this should actually be from the source. So put in the IPv that, or the CIDR block of where it's actually coming from. I just did mine anywhere because I was troubleshooting. And that was for demo 1. And then you do the same thing with outbound rules. It's just allowing all the traffic right now.
When you say put in where it's coming from, are you talking about using the 10.1.0.0.16 and the 10.0.0.0.16?
Yes.
Okay.
Yep. Let's see here. All right, this is demo 2. Inbound rules was the same thing. I did allow SSH, and then I don't think these are going to come into too much of effect. Just because I believe on our security groups, we're not going to get too in depth on this. So where we can just leave it as open for everything. If we want to lock it down, that's when we will only do from the actual source. And then outbound rules, I would probably do the same thing. That way we can, once we're in one, we can ping to the other and it's going to allow that traffic out. And then security groups. Let's see, what did I call this thing? Let me see. Launch Wizard 21, that's what I call it. We'll just go from here. So make sure you have port 22, and then I did leave it all open, but you're going to be doing this with your out of your private subnet when you're launching these EC2s. So it doesn't have like the standard internet connection. There's no networking for that. That's initially set up. And then that's outbound rules. So then the inbound rules, do the ICMP. I did the same thing. Let's try and lock this down afterwards, which I will start testing once I release you guys to do this. That way I have a definite answer for you. But make sure you have ICMP protocol on there. And I'll show you once we're launching this. So now that we have the two VPC set up and the peering connection, I've already set up these EC2s, but I'm going to show you how to edit which VPC you're. I think, have you guys already seen where to put or how to designate which subnet and VPC your EC2 instance will launch out of? Some of you may have, some of you might not have. That's okay. Go to launch instance. Say test one. See if we can load. My computer's been running a little slow today. Just selecting this Ubuntu server. Server type doesn't matter. Just use whatever. Just free tier, obviously. Instance type, give it your key pair. So select whichever one that you're going to use. And then when you can either create your security group previously or you can create it here. But this is important. So under network settings, okay, everyone remember this portion. Network settings, click edit. And then this is where we're going to designate which VPC this is going to be under. So I would select demo 1 first. And then this is where you can designate your subnet. If it's going to be in your private subnet, your public. So what I would do first is set up one in your public subnet. Okay. Have this enabled, auto assign public IP. And then select your security group. Was it 13? I think it was. Yep. So SSH, you don't have to have this HTTP. No, this one wasn't it.
I think it was 21.
It was 21. Yep, there it is. All right. So all ICMP, IPv4, ICMP, make sure you have open that one. You can designate your source later, and then your SSH, that's the same. This is only for ping. So if you're not going to be using ping, don't worry about this one. I just like it. It makes it easy. But then you can also do SSH. But with SSH, right, we're going to have to bring in that .pem file, do the chmod 400 and make sure it's in the right place. But if you only want to do your ping, it's going to be that Sorry guys, let me get some water. But yeah, then you just launch it. And then you can come back out and you can launch, say, one for your private in the second VPC, okay? So you come back for the launch instance. Say, oh, this is for VPC private 2. Just keep things easy, use the same AMI. Instance types still all the same. Select your key pair. Under network settings, go to edit. Then we'd select demo VPC 2. And then you could put this one in the private subnet. And then for the security group, it'd be the same thing. But launch. And then I'm going to do a little demo here for you guys to just show you that it can work. So we'll go here, get our SSH command, SSH in. So now that we're in the public VPC, let's see, where's networking tab? Just to show you. So this is, we're testing. Okay. All right, demo 2. So maybe they're swapped around right now, but that's all right. So we're in demo 2, subnet, it's in the public demo 2 VPC. And then since I've set up this, I can go to, let's see, let's go to networking here. This is in private one, or make sure it's in the other VPC real quick. All right, demo 1, subnet private 1. Let me get this private IPv4. There.